In the morning, we're talking about vectors, and I mentioned to say we exhausted almost everything on vectors. Vectors is going to help us to exhaust everything on Newton's laws of motion. The only topics which you need to be very much careful with is one, vectors, Newton's laws of motion, work, energy, and power. If you're going to understand these three topics, the rest will be easy for you. But as long as vectors is giving you nightmares, Newton's laws of motion is going to give you headache as well. If Newton's laws of motion is giving you nightmares, where we are going, there is nothing that we can do. If work, energy, and power is giving you nightmares, where we are going, there is nothing that we can do. So, the building block, the things which you did in semester 1, that's why it's very important for you to go back. This is different from math. Math, even if you don't know sets, there is no connection between sets and functions. There is no connection between functions and binomial. There is no connection between binomial and trig. Okay? So physics, you need to be connecting things. So here now, I'm going to explain everything which you need to know under Newton's laws of motion today. I don't want us to come back here and start talking about Newton's laws of motion. The next time we meet is going to be Newton's work, energy, and power. Then we jump to semester 2 work, where I believe you are going to enjoy as long as you are going to understand this. So, if you know that you are still having challenges with semester 1 work, the revisions which you have done so far, you watch the recorded videos which you've been having, and then you'll be able to catch up. If you are still having problems, please get in touch with me. I'll help you. Okay, so let's start our discussion today with Newton's laws of motion. So I'm going to be explaining using questions, but I'll be explaining everything actually. Let's start with this interesting question. A rope whose working strength is 2000 Newton is used to pull a 1000 kg car up a 10 degrees incline as shown below. Find the maximum acceleration that can be given to the car. We read the question again. Okay, so this question is coming from, it's important for you to know that this question is coming from which subtopic. Okay, so this question is coming from incline plane. So let me exhaust everything on incline plane. One thing we have to understand when we're talking about incline plane is this. So if this is my incline plane, let's have an object here. Okay, now let's assume to say there is nothing which is pushing this object, and here there is a theta, an angle which is theta. There is nothing that is pushing this object. If an object is on an incline, the only force which is there, if there is nothing at all, there is a force of gravity which we call Fg. That force is going to push this object to come down. So that force we call it Fg. We know that this is going to have the normal force, which is going to be Fn here. We expect to have again the weight force here. But this weight force, for us to support the normal force, we are going to have the y component and the x component. Meaning, this theta which is here is the same as the theta which is there. Mute your mic before I remove you. If you have got a question, you can ask. So now, the diagram which I have come up with here, guys, according to Sokato, I can start playing around with this guy. I know that this is the opposite here. So when we're talking about the opposite, meaning this is, so if this is mg, meaning this is mg sine theta, this is mg cos theta. Okay. Now, if we have got an object, it's just on a straight line, the normal force is equal to the weight force, which is mg. In this case, the normal force is in the straight line with mg cos theta. Therefore, we'll say mg, we'll say the normal force on an incline will be equal to mg cos theta. I've said mute your mic. Okay, and then you can clearly see that mg sine theta is in the straight line with the fg. Therefore, fg will always be equal to mg cos sine theta. These are the very important things which you need to know. I'm going to put them here. Fg is equal to mg sine theta. Fn is equal to mg cos theta, like that. Another thing which you need to take note, if there is no any force which is pushing this object, how do we find the acceleration? Like the way this diagram is, the one which I've just come up with. How do we find the acceleration? So we say the summation of all the forces in x direction, the only force which is pushing this object is Fg. As long as we're talking about incline, Fg will always be there. Take note, please. As long as we're talking about incline plane, Fg will always be there. So it's going to be Fg. That's the only force which I have. I'm not talking about this question, no. I'm talking about incline plane, which we're talking about here. From here now, I can clearly see that if there is acceleration, then where there is the summation, replace it with mass times acceleration. So I'll say ma is equal to, what is Fg? Fg is mg sine theta. Now in this case, I can clearly see that I can cancel m. So if this object is not being pushed by anything, you can find the acceleration using this formula. They only ask about acceleration here most of the times. Let me add more things. Let's assume that this object is being pushed by a certain force, and that force is pushing this object upward. Let's call the applied force Fa. What I'm trying to give you here is exact as this question here. Okay? It's the same thing. So now, how do we find the acceleration? So we say the summation of all the forces in x direction, the force which we have in this case, we have got Fg. Fg is pulling this object down, but the applied force is pushing an object to go up. Does that make sense? Now, what do we do? So we'll say the Fa, since it's applied force, minus Fg, because Fg in this case is acting as the friction force, is pulling the object in the opposite direction. So Fg will always be there, but they are not going to tell you that there is Fg. But you need to know that as long as we're talking about inclined plane, Fg is there. So we replace this by m times m to be equal to Fa minus, what is Fg? Fg is mg sine theta. How do we find the acceleration? Divide both sides by m, both sides by m. So m will go. What will be my A? A will be equal to the applied force minus mg sine theta divided by m. This question, like the way I've put it, is exactly as the question which we have here, because we have got the applied force as 2000 Newton. So the question is, what is the acceleration? You use the same formula. Acceleration will be equal to, the applied force is 2000 minus mg. What is mg? Mg, the m which we have is 1000 times 9.8 sine 10 degrees. Those having calculators, you can help me. Then we divide again here by 1000. So what you can do is you can say 1000 times 9.8. Nori, are you here?
Yes, I'm here.
I believe you have got a calculator because you are the one who was helping us. So 9.8, 9,800 sine 10. The answer I'm getting, I will do minus 2000, but I'm going to get negative and ignore it because I've started with that other one. Then divide it by 1000. I'm getting my acceleration to be 0.3. Confirm. Those having calculators?
Yes, 0.298,
Yes, yes.
which is 0.3 when landed.
Okay. Any questions so far? Any questions so far? We are good to go. Okay. So now another thing which we have to know is most they ask acceleration. What else can they ask? No, it's just acceleration. Let me give you another scenario. We're not talking about incline. The last one which they can ask. Let's say we have an incline, but this incline we have an object, and then so if there is friction, then it's going to be okay. Let's do this. Let's say there is friction. Okay, so let's say there's friction at all, meaning that for us to find the acceleration, we know that it's going to be the summation of all the forces. The force that is making this object to come down is basically the Fg, and we should remember that Fg is mg sine theta and Fn is mg cos theta. Let's remember this. So the only guy which makes this object to come down is basically Fg. So this Fg we need to do minus the friction force. Okay, so you're going to discover to say this summation is going to be replaced by ma, then Fg is mg sine theta minus what is friction force? Friction force is basically mu times the normal force. Okay, but what is normal force? Normal force is mg cos theta. Is mg cos theta. So you divide both sides by m. In this case, you can't even divide by m because you can clearly see that there is m here. You can cancel m. You can cancel m. Even here, m can go. So you remain with a to be equal to g sine theta minus mu g cos theta. If you want, you can say this is the formula for acceleration, or you can go further and factor out g. You remain with sine theta minus mu, then cos theta, like that. So that will be your formula. In a case where you have been told that an object is sliding down, you have not been given the force. So this object is going to be sliding because of Fg, but there is friction here which is opposing the motion. We are good to go. Another scenario. There are a lot of scenarios under incline, that's a problem. Let's say we have a case where this object here, we have got a force, the applied force, which we are going to be given. Okay, or let me do this. Okay, there is applied force which we are going to be given, then there is friction here. When finding the acceleration, what are we going to do? If you have really gotten the point there, can someone explain for us here? Hmm? My question is, we are trying to find the formula for acceleration, and we have been told that the object was sliding down with a certain applied force, which is this force, which we have just said Fm. Then there's friction. So which formula are we going to use for us to find the acceleration? That's the question. Mm-hmm.
I think you are supposed to look at the forces which you are having in x direction.
Okay.
Now, in this case, we have the applied force which is Fa,
Mm-hmm.
then I think plus the weight force.
Which weight force?
Minus the friction force.
Minus the friction force.
Yes.
But haven't you forgotten one force?
Force. Which force is that? I think it's the one, the weight force I'm talking about.
You're talking about, okay. Which force have we forgotten to include here, as long as we're talking about inclined plane?
The force Fg.
Fg. So where should I put Fg? Tell me now. Where should I put Fg, guys?
On the first one, sir. First.
Okay, so I've put Fa. Then should I put plus or minus? Yes. Plus Fg. Okay, so now since this no applied force is going in the same direction as what? The Fg. So I need to say plus Fg, then minus the friction force, like that. Then I can now start playing around with these forces. This is going to be mm, this is going to be Fa that you are going to be given, Fg is going to be mg sine theta, then this is going to be mu times the normal force, which the normal force we know that is mg cos theta in that case. Then you make A as a subject of formula. That is going to be the formula for acceleration. Now the last one, I want you again to tell me, what if we have got the applied force moving in that direction, we have the applied force there, then we have got the friction force here, and we want to find this object is moving in this direction, it's going up the incline. What formula are we going to use for us to find the acceleration? Let's do fast, guys. We move.
We can sum up the forces since it's going that side. The applied force will be positive.
Okay,
Then
so we
have
say
the
applied
friction
force.
would be negative, and the force of gravity will be negative.
Perfect. So I want you to understand, that's why it's very important to know what's happening here. So in this case, the friction force will be negative. Then Fg will also act as friction force because it's opposing the motion, because the object is going against the gravity. So it's going up. So now it's going to be minus Fg minus that. then you start playing around with everything, then make A as a subunit formula. As simple as that. Believe me, that is it for inclined plane. There is nothing more about inclined plane. Okay? Another scenario which is there under inclined plane is the question which is in the tutorial sheet for 1010. And that one I explained, where you have been given an angle, which this one was being applied at an angle. I explained that one. Okay, so if you didn't manage to find the video, let me know after the class. I'm going to send you the video. So that is it for inclined plane, unless you have got questions before we go to the next point, next subtopic under Newton's laws of motion. We are good to go.